somebody had asked me this question: if x comma y comma z is greater than or equal to 0, then x plus y, y plus z, z plus x is greater than or equal to what? And we have been given 4 options. So how to solve such questions? So I have given the hint that keep in mind that x, y, z are 3 positive quantities. Take any 2 at a time. So we will take any 2 at a time. But there is a concept known as arithmetic mean and geometric mean. So we need to understand this concept and this algebraic property because without it we cannot solve the questions of this sort, and there will be a lot many inequalities as this, wherein we need to apply AM is greater than GM. So first of all, we need to study the proof of it, that why is arithmetic mean is greater than or equal to geometric mean. What is the reason? There has to be a very sound logic. So yes, we have a proof for this. So suppose if A and B are two non-negative, that is A and B can be 0, but we rather would not take 0 because that will bring us to a very trivial result. But for our sake, for our convenience, we will say that these two are non-negative real numbers. Remember, A and B they are an element of positive real numbers. Okay, so they are strictly non-negative numbers. So now we know we can always subtract A minus B. Fair enough. We can always do its square. Not an issue. Okay, so what will this A minus B square is equal to? Obviously, this will be very much greater than 0. This whole expression will always be greater than 0. The only condition that A minus B can be equal to 0 if A is equal to B. Otherwise, if we are, okay, so even if we take A minus B, some even number raised to the power some even number, okay, some even power, some even number, this will stay very much greater than 0. Suppose if A minus B is strictly okay, so this is raised to the power some 2n, okay, so this will strictly be greater than 0, whereas 2n, this is always an even number, so this will always be A minus B greater than 0. So for now we will have A minus B whole square is greater than 0. Fair enough. What we in the first step we subtracted A minus B. We can always subtract two real numbers, any two real numbers, and if we square the subtraction, if we square the result, this will always be strictly greater than 0. The only condition it will stay as 0, it will be 0, it's when A is equal to B. So now what we will do is expand A square minus 2AB plus B square. This is again strictly greater than 0. Now we will add 4AB on both LHS and RHS. And why we are doing it? For now, just assume it, we are doing it for fun. We are doing it for just some sort of amusement. And this amusement is not mathematically wrong as well. Because whatever we are adding to the LHS, the same quantity we are adding to the RHS. Okay? So, mathematically we are not wrong. So, even if we take 4AB, 400AB, whatever be it, so whatever we have added in the LHS, we have added in the RHS. So there is nothing wrong about it. Nothing is mathematically wrong. So A square minus 2AB plus B square plus 4AB is greater than 0 plus 4AB. And adding anything to 0 will result in the same number. So this is 4AB. And now we can see this is A square plus 2AB plus b square is greater than 4ab. Is it correct? Yes, this is very much correct, because we see that 4ab plus minus 2ab, that will result in plus 2ab, because numerically the absolute value of 4ab is higher than minus 2ab, so we will end up getting a positive sign. And now solving it further, we will have the square of a plus b, the square of the sum of a plus b, which is greater than 2 times, we have split 4 into 2 multiplied by 2. Okay, and now what we will do is, we will take the 2 in the denominator of a plus b, in the square of a plus b, which is again mathematically very correct. We have just cross multiplied and nothing else. Okay, so before we do that, I've just skipped one part. Before we do that, it's 4ab. Now taking square root on both LHS and RHS. Remember, we can only take the square root or the cube root or any such kind of root, this procedure we can only follow when we are very sure of the left hand side being positive and right hand side being positive. We can only take the root sign or the nth root sign or the cube root or the fourth root or the fifth root only when we are sure of this property that both the quantities carry a positive sign in both LHS and right hand side. So taking square root will result us the square of a plus b is greater than 4ab square root of this, which is equivalent to saying a plus b is greater than twice of square root of ab. A plus b upon 2, which is greater than square root of ab. And now students, we can very well see that what is a plus b over 2? This is nothing but the arithmetic mean of two quantities a and b. And what is under root of ab? This is geometric mean of two quantities a and b. So we have just proved that arithmetic mean is greater than geometric mean. The only condition when arithmetic mean will be equal to geometric mean is when a and b turn out to be a is equal to b. This is the only condition when we can have a is equal to b, when the two quantities coincide, that is they are the same. Otherwise, in case of two distinct positive real numbers or real quantities, we will always have arithmetic mean is strictly greater than geometric mean, and we can combine the results. We can say arithmetic mean is always greater than or equal to geometric mean. So what we did was, here in this step, what we did was that it was written that a plus b is greater than twice of under root ab. So it was it was similar to writing a plus b upon 1 is greater than twice of under root ab. Okay, so this is like upon 1. So if we leave any quantity as, suppose we take any number 17, so 17 can be very well written as 17 over 1. There is nothing wrong in it, nothing mathematically wrong in it. So this is a plus b, we just cross multiplied, we just cross multiply 2 here and 2 here. Okay, we just cross multiplied the numbers. That 2 was multiplied to this, and a plus b was multiplied by 1. So what it resulted in, that a plus b upon 2 is greater than, or you can equivalently say that I divided LHS and RHS both simultaneously by the number 2. And if we are dividing or multiplying by any positive number, the sign of the inequality will not change. Suppose if we have a greater than b, and if I multiply it with minus 1, okay, minus 1 times a, minus 1 times b. So here is a caution. The sign of inequality will change. So it will be like minus a is less than minus b. Suppose if I have 6 is greater than 5, and if I multiply it with minus 1, so it will be minus 6 is less than minus 5, which is actually true that in negative numbers, the higher modulus numbers are always smaller than the lesser modulus numbers. Okay, so this thing has to be kept in mind, that if we divide or multiply, this happens only in the case of division and multiplication. See, if we have a is greater than b, and if I add minus 2 and if I add minus 2 both here, okay, so the sign of inequality will not change. But it happens in the case of multiplication and division, that if we happen to multiply it by any non-negative number, so we have to change the sign of inequality. But in this case, in this particular case, we just didn't have any need to change the sign of inequality, because we divided both LHS and RHS by some positive quantity, that is a plus b over 2 is greater than square root of ab. This is what? This is arithmetic mean of two numbers. This is what? This is geometric mean of two numbers. Hence, we have proved that the arithmetic mean is greater than geometric mean. Okay. So, a plus b upon 2, which is the arithmetic mean, is greater than square root of ab, which is the, or we can write ab raised to the power half. So, now, coming back to our question, which was, suppose if we have quantities x plus y, suppose if I have quantities like x plus y, y plus z, and if I have z plus x. So applying am is greater than gm in this, so what will it be like? X plus y over 2 is greater than square root of xy. Okay, so I just applied am, arithmetic mean and geometric mean in this x plus y. X and y are two. We have already been given that x y z is strictly greater than or equal to 0. Okay, so for now we will assume that they are not even 0, they are just pure positive real numbers. So x y z are pure positive real numbers. So for now, in this case, we have applied, and this we can term it as equation 1. Okay, and now moving to the other part, y plus z. Root yz, this is equation number 2. Z over x, this is under root zx, this is equation number 3. And now what we will do is, we will multiply equation 1, 2 and 3. You can always multiply any quantities. There is nothing mathematically wrong in it. It is very much consistent with the mathematical operations. So now we will get as the result, we will get as x plus y over 2, y plus z over 2, z plus x over 2, root xy multiplied by root root xy, root yz multiplied by root zx. So this is going to be like x plus y multiplied by y plus z multiplied by z plus x upon 8, and in the square root we will have x square, y square, z square. Okay, so remember one thing, that if we have three quantities or two quantities, suppose if we have two quantities a and b, this will be equal to square root of a square root of b if and only if a comma b belong to positive real numbers. Or suppose if we have under root square root of a, square root of b, square root of c, or any number of quantities, so this will be like square root of a dot b dot c, like let's say however many quantities, but the only condition is that a comma b comma c and all the quantities have to be strictly greater than 0, that is they must belong to the set of positive real numbers. Okay, okay, now the last step we will do is x plus y, y plus z, z plus x divided over 8 is greater than x y z, which is equivalent to writing x plus y, y plus z, z plus x is strictly greater than 8 times x y z. And we just proved that x plus y, y plus z, z plus x is greater than 8, where x, y, z is strictly greater than 0. So we just proved that this value is greater than 8xyz. So in the question, the option A is correct, that x plus y, y plus z, z plus x is greater than 8 times xyz. The only time when equality will satisfy, that is the LHS and RHS will be equal, is when x is equal to y is equal to z. And remember in mind that these three quantities are strictly greater than 0, they are positive real numbers. And what we have done is we have just applied AM is greater than GM on the three quantities. We just formed three equations. X, this was equation number 1, this was equation number 1, this was equation number 2, this was equation number 3, and we multiplied by equation 1, 2 and 3, and what we ended up was a result, that is x plus y, y plus z, z plus x multiplied, we have just multiplied everything, just multiplied the three equations, and we end up getting x plus y, y plus z, z plus x upon 8 is greater than square root of x square plus y square plus z square. Remember this is equal to writing, this is equivalent to writing only if and only if this condition satisfies. So what we end up is getting x plus y, y plus z, z plus x upon 8 is strictly greater than x times y times z, and upon cross multiplying we can we can just multiply the LHS and RHS by 8. We will have this result. So that completes our proof, as well as a very good application of arithmetic mean is greater than geometric mean. In future we will solve a lot many more questions upon these inequalities. For now, thanks for watching the video.